Okay, Jdbc, Java Database Connectivity. Probably this is one thing that you will have in every project. Without database, there is pretty much no implementation nowadays at all. And most of the times you come across Oracle database. But if it is Oracle or any other database, WebLogic almost supports 15 to 20 databases inbuilt. Then there are about 15 to 20 which are we can explicitly manually configure. But any project, pretty much you have a database. Now what we're going to see is how WebLogic helps an application acquire a connection to the database. You will see how WebLogic manages the connection to the data, how it creates a connection, and when an application is asking for such a connectivity, how it provides it. Now this is what actually happens when an application is looking for a database connection. This is the flow that you will look at. So let's just one moment. Okay, here we go. So here is your application. Basically, we have deployed the application on top of WebLogic. Now this application wants a connection to the backend database, which is this one. Now the application is expecting that the connectivity, this thing, be provided by WebLogic application. So now what we're going to see is how WebLogic application servers provides this entire infrastructure. Means what are the various components that this infrastructure, how WebLogic creates it, how WebLogic manages it, and finally when an application asks for such a connection, how this connectivity works. That's what we're going to see. Now the first things first, application first looks up as usual the JNDI. Anything that the application requires, it goes to the JNDI, Java Naming and Directory Interface. Now if I have to explain JNDI in a regular words, not in a Java technical words, JNDI is like a notice board. Let's say it's a very simple service provided by your app server. A notice board, an application can come to the notice board, it can look up the notice board, find out the corresponding point of contact for any service. In this case, the one that you're looking at, application is coming to the JNDI. It's looking up for an object called data source, the green box. The data source object is basically the source of this database. Means the data source will have all the details of the backend database you are looking at. Means it will have the details of what database it is, name of the database, what host name it is running on, what is the port number where it is running at, what's the username, password to connect to the database. Means the entire details of the database are stored with the data source. Here the information of the DB is not stored in the application is pretty much it simply asks for a connection. Now once the lookup is done, means on the JNDI, once the lookup is done and the application gets a data source on the back end has what is called an associated connection pool. This one, a connection pool, in the sense as the name itself says, it's a pool of connections. Now you're looking at a group of connections here, connection 1, connection 2, like that. There are lots of connections. Now each of those connections can provide connectivity to the backend database, to this one. Now one of these connection objects will be given to the application. One of these connection objects, if it is available, assuming we have sufficiently large connection pool, one of these connection objects will be given to the app. Now once the connection object is given to the app, a connection object cannot directly interact with the database. There is no such thing as direct interaction with the database. Anybody who is talking to the database has to do it through a driver. This driver is the one who facilitates connection to the database engine. Now here again, what we are actually doing is, so application looks up the JNDI, it gets a data source, this one, then the data source will ask the associated connection pool for a connection object. Every data source has one connection pool associated with by default, not more than one connection pool, only one. We will be allowed to increase the size of the connection pool depending on the load on our application. One application may require only one connection to the database, and depending on the load, another application may require lots of load, lots of requests to the database. So the pool size changes according to the load, and we have to configure it, tune it. Now once the connection object is given to the application starts establishing a connection to the database through the driver. That's the flow. Now what we have to do as an administrator is to configure this part. You will configure the data source. You will configure the size of the connection pool. We will configure the driver, what type of driver it is. These three things. Now to configure it, you'll need two pieces of information. One is the database details itself. Means where it is running, what's the IP port, those details. Now those you will get it from the DBA. The other piece of information is the application. Means application is looking up the JNDI for a specific data source. Means the name of the data source is already hard-coded in the application. Let's say here in this case, the diagram you're looking at, DS, that's the name of the data source, which is hard-coded in the app 1. So the developer is going to tell us, create a data source with the name DS. Now we're going to create a data source with the name DS. Once we deploy the application on top of the app server, when the application looks up the JNDI, it should be able to find the data source that we have created. Once it finds the data source, the rest of the things are already configured. Rest of the things in the sense, this entire part. Connection pool, drivers, within pool you have connection objects, which will let you connect to a database. Now that's a very simple flow of how WebLogic creates a connection to the database, how an application acquires a database connection. Alright. Now all these things we have to configure. Now configuration of this thing is pretty straightforward here. The sizing of this one is little tricky. Means we cannot randomly give a size of connection pool. It has to be thoroughly tested, and or we have to do a trial and error method. In a normal production system, the connection pool size is anywhere between 100 to 150. Means there are 100 to 150 connection objects at any point of time. Now 150 may be sufficient or it may be too large, so we need to, let's say, start with 150. You run it for a couple of days, then no issues, then decrease it to 100. Let's say you have a problem. You will see in the logs that could not acquire a connection object, which means 100 is insufficient, 150 is sufficient. So somewhere in between 100 and 150 is your number. So you need to increase it from 100 to probably change it to 120. See if it is working. That's a trial and error in production, but that's not something that's recommended. You should get your numbers correct during the load test. When we are doing the load test, you will be able to identify what kind of load will require what size of the connection pool. That's part of your overall testing strategy. But as an administrator, our job is to create this entire infrastructure and manage it. Alright, let's move on. Now this is the flow as we talked about. Your application is looking up the JNDI. It obtains a data source from the JNDI. Now the data source checks with the connection pool that is associated with it. Connection pool is nothing but a pool of connection. Now if a connection object is available, it gives a connection object. Then application establishes the SQL connection with the using that connection object through the driver, alright, with the, to the database. Now there are a couple of words here. Already we talked about data source. Means data source is the one that is bound to the JNDI. It's an object bound to the JNDI. So if you look at on this diagram, this is your data source. So this is an object. It's bound to the JNDI. This has all the information about the backend database. This also has a connection pool associated with it. This also has a certain driver information. Now all these details are actually part of the data source. Then a connection pool is a pool of ready-made database connection objects. One pool is available or associated with each data source. This is wrong here. Each DB, this is wrong. Data source. Then the connection object. Connection objects are basically what a pool consists of. Our connection object is the one that is actually providing the connection. All that we have is, because one connection object would not be sufficient, we are maintaining a pool of connection objects so that we can handle or satisfy multiple database requests. Now the next thing about in this diagram, you will see the important one is the drivers. Now it's not that important, but the way drivers have developed is interesting, and sometimes it might help you troubleshoot certain things.
Yes.
So we're going to look at yes.
This is Kalyan. I
Yes,
just
yeah.
have one doubt.
Yeah.
As you said, how will the application will look up the JNDI, like as you said in the flow, and will it?
It has
suppose
a
the
code
application-
called getup. If you look at this one, hold on. This is the kind of code you will see. Let's say I open up Notepad. The kind of code you will see, if you are a developer, you would write something like this: look up JNDI for data source. This is a code. Get connection. This is your database. The Java code that you will write. That's a way of looking up. This is a function.
So suppose if the application is deployed on some managed servers, not an admin server, so JNDI would be on every server, right? Like inbuilt.
Yes. JNDI is offered on every JVM.
Okay, every JVM. So if suppose the admin server will also, the application will look up on the admin server also.
No. Application will look up on the local JNDI, which means the local JNDI should have the data source. So as an administrator, we have to target the data source to all the JVMs or all the managed servers wherever we want the application to have this connection.
Okay, but even in their code, they have to write that it should be what we say. It should be related to admin console URL also, right, sir?
Why?
Like I have seen one some troubleshooting issue or there was an issue like JNDI is already existing to the other URL, so they have changed the server name actually to which it has to be connected. That means it's like admin URL. We have like 2 data centers in our environment.
Okay.
Actually, the JNDI was targeted to the first data center, but actually speaking, it should target the second data center. So that was a main issue by which it couldn't look up the JNDI and data sources were not available for the application. So it was going into prepared state. For about 4 hours we tried it and then it got resolved.
So your application is supposed to look up a remote JNDI. That's what you are saying.
Yeah, like a JNDI provider will be there, right, sir? In their code, will they handle that, right?
No, an
Like in their,
application can be written in any way. Normally, the to make it simple or to keep it simple, are
okay,
not to hard code things. What we usually do is when you are writing look up the JNDI, you mean the local
okay.
JVM.
Yeah, that's what
Local
I
JVM is the default lookup. But if your application requires, so probably what I'm assuming is your application has a
they
remote
have like a
JNDI.
JNDI provider URL, sir. That's what I was confused.
No, JNDI
Normally,
provider URL is your JVM. Even if you say a regular managed server, that's a JNDI
okay,
provider.
okay.
So your IP
Yeah,
port
that's
of the
what.
managed
But
server
actually,
slash JNDI becomes the JNDI provider URL.
okay, okay.
In
So,
your case, what happened was there are some objects which are bound to one JNDI and your application is expected to connect to that JNDI.
okay,
So that's the reason you have explicitly asked the Java program to connect to that JNDI, the remote data
okay,
center in your case.
okay, okay, okay. Yes, sir.
Means
Got it.
when we are creating the data source, I think
Mm-hmm.
somewhere you guys have targeted it to the JNDI provider that you have used. Means the data sources are not targeted to every
Local
JNDI.
JVM, right?
They are targeted to only one JNDI. We are expecting the application to reach that JNDI in every scenario. Probably
Okay.
that's some requirement in your project.
Yeah, that
Yeah,
application is
so
mainly like web services, sir. So that could be the reason, I hope.
yeah, probably what they are doing is they are instead of having it everywhere, they are having it at a centralized location, and the application will look up the remote JNDI, and once it gets a data object, it moves on from that point onwards.
Okay, okay,
The
okay,
implementation is little different there.
okay, okay. Yeah, yes, sir. Got it. Thank you.
All right, so let's move on. What we are trying to look at is the drivers. Now, drivers have actually been developed in a chronological way, means probably from 1995 when the connectivity to the database has really picked up fast. Means applications really needed to connect to the database. Means that's the time when Java was actually picking up, 95 90s. When that started picking up, the driver became a very important element about how a how a Java program connects to a database. So there are a lot of types of drivers that are developed, especially to be precise, there are four types of drivers. Means the four type of drivers means they are not developed at a time. It's not something like you have in 95 there were type 1, type 2, type 3, type 4. There are no such thing. In 95 you got only type 1 drivers. They were enhanced, then they called it type 2 drivers. Then they were enhanced further, they were called type 3 drivers, and currently we have what are called type 4 drivers. So it means current usage is only for type 4 drivers. Type 1 drivers nobody really uses. So what we're going to see is what are these types, how do they actually differ in terms of their implementation. So it's more like a theoretical aspect. So we will be using always type 4 drivers nowadays. Type 1 drivers, if you say, they were the original drivers actually. Means that's when every program wants to connect to a database, so they needed some kind of driver. So if you see it, if there is a Java program, so that's a Java program, they used to use what is called a ODBC driver. There was no Jdbc driver at that point of time. This is open database connectivity. Now what we are talking about is Java database connectivity. When you say open database connectivity, what we actually mean is any program. It's not necessary that it has to be a Java program. Any programming language, C, C++, Java, COBOL, take anything. Any of those programming languages can use this commonly available ODBC connectivity code, and they can connect to a backend database. Now, obviously, this is a generic code, ODBC. It's not optimized to perform better. It simply is created to provide a connection to the database. It may not provide a better performance, but those are the ones that actually were available at that point. So what we have here is you have ODBC code, which is this one, all right, and then there is a Java program which will write the implementation part to connect to the use the ODBC, connect to the database. So because there are two elements here, one is from the Java program here, other one is ODBC, we usually call it a bridge driver. So the first type of drivers are called bridge drivers. The bridge drivers have used ODBC code. Now the ODBC code was provided free of cost by Microsoft. Even now it does. So Microsoft is the creator of the ODBC connectivity code, and any program can use ODBC connection to connect to any database, not just Oracle database. These were the original drivers which were used to connect to a database. Now once they are done, they were being improved, just to offer a better performance, a better connectivity. Then the type 2 drivers arrived. Type 2 drivers, it's a simple upgrade kind of thing. Earlier you used to use the code provided by Microsoft. Now what we are doing is, instead of using the ODBC code, we are using the code provided by the vendor itself. Now if you see Oracle database, Oracle started providing a code. A code is written in most of the times in C. So you got a native API, which is a vendor provided piece of code. Instead of what we have ODBC earlier, now we have the native API. Then your program part really remains same on this side. You will still write the connectivity code to the native API using the vendor provided driver. Alright, so these diagrams may not be really accurate, but we are getting a general idea of what actually happened. So initially we were using ODBC. Our program will use ODBC to connect you to the database. So we had a bridge, type 1 or bridge drivers. Now instead of ODBC, we replaced ODBC with something given by the database vendor. If we are using Oracle database started giving you a piece of code. Now that piece of code we have used instead of the ODBC code. Now that's usually called the native API. Once you started using native API, they're called type 2 drivers. So type 2 drivers are basically, they don't use ODBC anymore. They got a little bit better performance, if not too much. So every vendor started giving the native API, Oracle, DB2, Sybase, Teradata, anybody. Then this has improved further. Means during the next years, it moved on, it improved further. We came to a stage where we have type 3 drivers. Now the type 3 driver, if you say, it's a modification of type 2. In a sense, let's say you got a bank, a small bank at that point, where there is a central database and about 100 employees in the bank. Now most of the applications during type 3 are client server applications. Means there is a centralized server. The client is installed on all your desktops. Now in the scenario that I'm giving, all 100 employees sitting in your bank premises have an application installed on their desktop. Now that application will connect to a database which is centrally located on a server. Now when such a scenario is there, the driver, which is type 2 driver, if we are using, the driver has to be installed on all the 100 desktops. Now if there is a maintenance tomorrow or an upgrade tomorrow, we needed to upgrade on all the 100 systems. So that used to be kind of labor intensive, so you have to have skilled IT person to do that, and there are problems with your upgrades, all that stuff. So what was done was, instead of installing the driver on the desktop of all the 100, let's move the driver into a common machine. Now that machine at that point of time used to be called the middleware component. So type 2 driver, you have the driver on all the 100 desktops, but in type 3 you don't have the driver on all the 100 desktops. You have it on a centralized server. A centralized server used to be called middleware server. Now middleware nowadays has a complete different meaning, but at that point of time, probably we're talking about 10-15 years before, the middleware component is basically the server that hosts the driver. So now instead of having the driver everywhere, we have the driver on a centralized server. So the client will connect to the centralized server or middleware server first, which will let you connect to the backend database. So now this type of driver where you have a common middleware component is called a net driver, because we are using a network kind of thing. So it's either called network driver or it's called a net driver, or in a very generic sense it's called a type 3 driver. Then the improvements have started coming in, and then you finally have today's driver, what is called a type 4 driver. Now by the time we arrived here, now the drivers themselves are written in Java. They're not written in C anymore. Now because they are written in Java, obviously if you are using a Java program on the other side, so what happens is, here you have a Java program, your driver is also written in Java. So obviously there is no bridge kind of setup here. The entire thing you are looking at is a homogeneous setup from top to bottom kind of. So because of this reason, it's called a pure Java driver. Everything is Java here. So it's called a pure Java driver. So a type 4 driver, it is called pure Java driver. Another thing is, it's called thin driver. The reason is, a thick driver usually, as opposed to thin, obviously you will have something called thick. A thick driver has multiple technologies, or it's heterogeneous. Means one program, a program could be C, then your driver is written in Java, then the implementation connectivity, that's a thick program. Whereas here everything is Java. So either you call it pure Java driver or you call it a thin driver. Now these are the drivers that we are going to use currently, and all the databases, all your projects are currently using type 4 drivers. So you have type 1, 2, 3, 4. Currently the ones that are being used are type 4 drivers. Type 1 are bridge drivers, type 2 are API drivers, type 3 are network drivers, and type 4 are pure Java or thin drivers. Alright, so you will be depending on implementation and programs compatibility, either you will be using a type 2 driver or type 4 driver. If we don't know what driver we want to use, we will use the most advanced, the type 4 driver. And WebLogic comes with certain for certain databases, WebLogic comes with these drivers inbuilt. Means when we install WebLogic, it also has installed these drivers for the most popular databases. I'll show you what are the databases that are by default supported. For those databases, the type 4 driver is already installed. We can simply choose from a drop down. So this is a summary. Type 1 is a bridge driver. So you got basically a Hdbc code provided by Microsoft plus a Jdbc, so Java program. Then type 2 is your native API. It basically gets provided by the database vendor, Oracle, IBM, or anybody, whoever you are buying the database from. Then type 3 is where you have moved your drivers onto a centralized server. It's called a middleware host, so it's called a net driver. or network driver, anything you can call it. Type 4 are your pure Java drivers. You also call them thin drivers. And these are the ones that are being currently used. Now, apart from these things, means the type 4 drivers or type 1, type 2, any of these drivers, you will come across another situation in your, when you are performing a transaction, that you need to contact multiple resources during your transaction. For example, take this example here. Let's say you have a banking application. So you logged into your bank account. Assume you got two accounts. One is you have a savings account, and then you have, let's say here, this is savings account. Then you got a, let's say for example, a current account with the same bank. So that's the important thing here is we have the same bank. Let's pick up another one. So you have another account with the same bank. This is current account. Now you have this application which you are using to operate any of these two accounts. Assume your bank stores all its savings accounts in one database, something like DB1. All current accounts and their information is stored in a different database, let's say DB02. So database 1 stores all the savings accounts of Citibank. Let's say we take the bank also precise, and Citibank has a different database DB2 for storing all its current account customers details. You got an account with Citibank. Now obviously, let's say you got both the accounts, savings account, current account. Now you will be given a login. You can log into that account. Now once you logged into the account, you are trying to transfer some money from your savings account to the current account. Now obviously in that case, you have a connectivity you need from, this one. So you need to connect to the savings account. So deduct or execute an SQL query that will probably take the money out. Let's say you are transferring 10K from savings account to current account. So deduct 10K from this balance, and the same way add 10K to your current account. Now there are two SQL queries involved. More importantly, there are two resources involved. Resource 1 is your database, savings database. Resource 2 is current database. Now obviously these two SQL queries cannot be executed one after the other. The problem is, if they get executed one after the other, what happens is, let's say we are done with updating the savings account, means we have deducted 10K from your savings balance, but before you update it in the current account here, let's say the entire system crashed. Means your transaction is halfway. Now there should be somebody to manage that half transaction. Otherwise what happens is, if you commit the data on savings account, you lost the 10K, but they were not updated anywhere on your current account. Means there are certain transactions that need to be executed either completely or it should not even start at all. They cannot be halfway like the one that we are talking about now. Means you cannot only update savings account but not the current account. Obviously your savings account is already deducted. So you need somebody like in WebLogic, what you have, a transaction manager. So there is a transaction manager here which manages this entire transaction. And when you have a transaction which requires multiple resources contact, you call that transaction a global transaction. So now a transaction manager is there. A transaction manager is managing a transaction that has multiple resources, in this case 2 databases. Now the transaction itself has to use a certain protocol. Now that protocol is usually called a two-phase commit protocol. Means because there are two transactions, SQL1 updates database 1, SQL2 updates database 2. Now this is what usually happens, the regular flow that we are looking at. Now any of these global transactions, a global transaction is basically two resources. Now let's not worry about that screen yet. So we have a global transaction now. A global transaction, multiple resources. When there is a global transaction, the way we usually implement is in multiple phases. Let's say phase 1, we get ready all the databases. Means we say database 1 execute an SQL query, subtract from the balance, but don't commit the changes. So everything is prepared, ready. The same way database 2 also, we add that plus 10k, we don't commit the changes yet. So database 1 and database 2 are ready. They have done all the changes, they are in the buffer but not committed yet. Now the transaction manager is coordinating with database 1 and database 2. Now once DB1 and DB2 says yes, we are done with all the changes, we are ready to commit, then it moves on to the phase 2, which is called a commit phase or rollback. So stage 1 is a prepare stage, stage 2 is a commit stage. Now stage 2 will commit everything if stage 1 is successful. Means everybody in stage 1, all the resources, DB01, DB02, all of them said yes, we are ready. Then stage 2 will be commit stage. In stage 1, let's say one of the resources said no, it was not done for some reason. Then stage 2, it will roll back all the changes that are performed in any of the other resources. Now this phased manner of executing a global transaction. So what's a global? I'm redoing everything. A global transaction is when you have multiple resources. In this case, we are talking about two databases. To manage a global transaction, we are using a phased manner. Phase 1, we are preparing everybody, all the resources, not committing the changes. Phase 2, we will commit if prepare is successful. We will roll back if prepare is not successful. So this phased manner of execution or this protocol is usually called a two-phase commit protocol. So a global transaction usually completes in two phases. You got phase 1, it prepares all the resource managers and resources of individual databases. Then once phase 1 is complete, moves on to phase 2, which is a commit phase if everybody is successful. If any of them is not prepared, even if at least one of them is not prepared, then the entire transaction is rolled back in phase 2. So this phased protocol or two-phase commit protocol, it's usually called, is used to implement any global transaction. Now to implement such a two-phase commit protocol, your driver should support it. Whether it's type 1, type 2, type 3, type 4, your driver should be capable of supporting a global transaction, or it should be capable of supporting a two-phase commit protocol. And any such driver that supports a two-phase commit protocol is called a XA driver. So there is an XA driver. The XA driver, the major difference between an XA and non-XA is an XA driver supports two-phase commit protocol. The driver can hold or the driver can listen to a transaction manager. So the transaction manager uses the driver to contact the database. That's what we've been telling. But the driver, does it support a two-phase commit protocol is the question. If the driver supports a two-phase commit protocol, we call the driver XA driver. If the driver does not support two-phase commit protocol, we call it a non-XA driver. So in type 4, which is a pure Java driver, you may have a piece of code that supports XA driver. You may have a piece of code that does not support non-XA driver. Now if you see in Oracle database, you will see most of the times XA driver, Oracle database, and the drivers really support XA and non-XA. But there may be some programs or there may be some databases that cannot support a two-phased commit protocol. So in that case, you can't use a XA driver. So, but in general, when somebody says XA driver, so you're backend that you're looking at basically two-phase commit protocol. And why you need a two-phase commit protocol? Because there is a global transaction. What's a global transaction? Multiple resources are involved. Alright, any questions in this one? This is a little confusing. Probably this is the first time you come across. Any questions in here? You can ask me. Okay, so let's summarize. So you got four types of drivers: type 1, type 2, type 3, type 4. Type 4 are the ones we are using, which are thin or pure Java drivers. Now, even for a pure Java driver, if there is a global transaction it has to participate in, it should support a two-phase commit protocol. Global transaction is multiple resources, or in this case precisely multiple databases. A global transaction is managed by a transaction manager, but it should be supported by the driver we are talking about. So if the driver supports a global transaction, the driver is called a XA driver. If the driver is not supporting a global transaction, we call the driver a non-XA driver. Alright, so that's your XA driver. Any driver that can implement a two-PC or two-phase commit protocol is XA driver. Now all four types of drivers can actually have both implementation, XA and non-XA stuff. You will usually see type 2 and type 4 drivers being used most of our environments, especially type 4 XA drivers. Now who decides what we need to use? Obviously the developer, because the transaction nature is known only to the developer. Only the developer can know whether the transaction is a global transaction or it uses a single database. So the developer is going to tell us what kind of driver we are supposed to use. Now if we are not getting any information from the developer, or we are doing some kind of troubleshooting, we can start with type 4 XA driver, which is probably the most advanced driver which can take care of any type of transaction. Now here, coming back to our practice part, we're going to use a database that came with the Medrec domain. If you remember, we have taken our application from Medrec application. Now Medrec also comes along with the database. Let me just show you that database. So I'll log into the cloud server. Okay, so that's our cloud server now. It's really slow. Oops, a lot of process running here. SOA server 1. I am killing all the Java process. Now this is a command you will be using if you want to kill all the Java programs running on your system. So this is what I'm doing. I'm first searching for Java programs. I'm filtering this grep command which you see here, because that's not a Java program. Then I'm stripping off this process ID, which is this. So I got all the process IDs then I'm using xargs to kill all those processes. Oh, this is not the owner. I'm using encode. This is started with another user ID and cd. I can just let me kill it. Okay, we're good to go. Now let's come back. So we're talking about the database that we are supposed to use. Now the database is associated with the metric domain that we have used. So let's go to the location of the metric. And the good thing is, for practice, to make it easy for us, the startup and shutdown of this database was included in the startup and shutdown of WebLogic itself. Means if we start the metric server, the database also comes up, so that we don't have to really worry about how to start and stop the database. But in real time, you would never really require that kind of setup, because there are always DBAs who can take care of the database part. All that we have to do is, you should get the details of the database. That's it. These details: the name of the database, port number, where it's running, host, and user ID, password to connect. But in our case, we're going to start a database. This is a point-based database, not Oracle, but it's exactly same for Oracle also. WebLogic does not distinguish what type of database it is. Any database, the same setup. So I'm going to start the point-based database first. Then we will come back and see how to create a data source to connect to that point-based database. And to start the point-based database, I'm going to simply start our metric server. So let's go to the location where we have metric server. Online BA10G, that's BA home. This is WL home. Samples, domains, metric. This is our location, so we've already been here. This is a metric domain. Now we have only one server, so you can start the server from here itself. This is a metric server. This is the name of the server. Look at this one. Now, the reason we are starting this server is we wanted a database. Only for that purpose we are starting. Other than that, this server itself is not useful for us at this point. And this server comes up, it also brings up a database along with it. So let me open a new session to the same box. Duplicate. Alright, so if you check for a point-based database, see, this is the point-based database. Started just now, 5:55. Just now. Alright. And also it's running on a port number 9082. Now that's wrong in the document. In the document it's given 9083, so make sure you make a note of it. So 9082 is the actual port number where your point-based database is running. And the name of this database is metric. The username, password to connect to this database is also metric. So these are the details. This is the database name metric, port number 9082, DB host, the same box, username, password, metric. So we're going to use these details to create a data source on our domain, and then target that data source to all the managed servers. So let's do it. You will get a better idea then. So I'm going to start our admin server first. So let's start our admin server. Let's go to domain home, online BA10G, WL server, samples, sorry, not WL server, ours is under user underscore projects. So user underscore projects domains encode DMN. So let's start the admin server using the wrapper script. For medrec we did not create any wrapper script. For our own domain we have the custom wrapper script, so I'm using that custom wrapper script. What is this error? Okay, this is a startup class we were testing. That's fine, that's okay error. Now your admin is running mode, so we can actually log into the admin server. Let's also start one of the managed servers. Start mng1, so that will be coming up. This is a log file. Let's log into the console. Let's get the IP port of our admin server. This is our admin console, so let's log in. WL07 admin. Alright, so we have seen how to create servers, we have seen how to create clusters and some of the other things. We've seen how to deploy. Now we're looking at the services offered by WebLogic. So click on services. Now in the services, select Jdbc related services. So this is what we are looking at, Jdbc. Alright, in Jdbc you got data sources. This is what we are trying to create. So click on the data sources. Now there are currently no data sources in our domain. So let's look at the servers. So these are the servers we have in our domain. Alright, one admin, we have 2 servers on first box, another 2 servers on second box. Only one of them is running. I think we have started mng1 only. It's running. The rest of them are actually down. They're all part of a couple of clusters. Now let's get back to the data source. So services, Jdbc data source. You can create a new data source. Now look at this one. This is the name of the data source. Let's say we call it DS1. The JNDA name is what comes from the developer, because this is what is actually looked up in the JNDA. In the application, this is what is hard coded. And normally all the JNDA has a naming convention like what type of object it is, like Jdbc type of object. What is the name of the object? This is the naming convention of JNDA. Because JNDA, we said, is a notice board. Means a notice board can have any type of object on it. It can have a Jdbc object, it can have a GMS object, it can have some other kind of object. So just by looking at the name itself, you won't be able to tell what kind or what type of object. So as a best practice kind of thing, all developers use this naming convention. It's recommended. So give what type of object it is, then give the name of the object. It's not mandatory, but that's how it's supposed to be. So the developer is going to tell you what is the JNDA name, and you have to use the exact same name. Otherwise, the application will not be able to look up your JNDA. So once you're given the name, the driver details we have to give. Basically, select what type of database we are using. Now this is a list of databases that have inbuilt drivers. WebLogic, when you are installing, it has all these drivers by default. Means the support for these databases is inbuilt. You don't have to really do anything. Just select the driver, it gets it lets you connect to the database. So in here, the most popular one being obviously Oracle. So if you see Oracle, let's say. Now Oracle has a lot of drivers. Means there are type 4 XA drivers, type 4 non-XA drivers. Now there are certain Oracle drivers provided by BA itself. Then there are certain Oracle drivers provided by Oracle. Then there is another company, Data Direct. Then Oracle's driver, OCI drivers. So here, lots of drivers. If you don't know what driver you need to use, the safest one is to use the Oracle driver, thinXA. Now this is compatible with any of these versions of Oracle database. You can use 901, 920, 10G or 11G of Oracle. Any of these databases, the same driver. So once you've selected it, you can move on next. Now that we don't have an Oracle database, I'm selecting a point-based database. I think we have an Oracle database. We have it for SOA, so let me try if we can connect. We got a database. These are database. We have a database. I'm not sure if we can actually connect Oracle. The listener is running. I think it was not set up properly. Something is wrong here. We can try it. Let's give it a try. Why worry too much about it? So let's say Oracle database is running on the same box. Now it's going to give you the transaction options. Basically, it's going to tell you you have selected a XC Jdbc driver to use to create database connections with the new data source. This data source will support global transactions because you are using AXA. Now when it is supporting global transaction, it will use the two-phase commit protocol. No other transaction configurations are necessary because it's already supporting two-phase commit protocol. So once you have selected it, this is more like information because you have selected, you will have support for global transaction using two-phase commit protocol. That's what the meaning is. On to next. This is where you're going to give the details of the database. If we have used point-based, we will give the point-based details, but we have tried Oracle, so let's go ahead and give it a try. A database name is encode.it. Host name is the same box it's running on. Port number 1521. Database username, I think we're going to use SOA DBA. Password encode.it. Password encode.it. We'll just see. We will test the configuration. So you have given all these details. See the details we are giving. What are the details we are giving? Name of the database. Where is it running? What port number it's running? Username to connect to it. Password to connect to it. Just simple information. On to next. Now based on the information that you have given, Oracle actually prepares what is called a Jdbc URL. So this is sometimes a very important one. You will be changing this one a lot of times. This URL has been constructed by WebLogic for you with all the details you have given. So we have selected XA type 4 driver. This is the host where the database is running. This is the port number, and this is the name of the database itself. Apart from that, this is the driver class, the type 4 driver, pure Java driver. We are saying it's a Java driver, right? So obviously there is a class associated with it, and this is that class. And the other details that we're given is for DBA and username, password stuff. Alright. Now you can actually test the entire configuration before creating the data source. If everything is good, yeah, I think it's good. So you get a connection succeed. Or if something is wrong, let's say you're given a wrong database name, let's go with DBA1, now test it. You see, this is the error. Test connection failed, invalid username, password, login denied. This is an error you got from a database. Now let's try it again. Test connection with proper information. It succeeded. Alright. So this basically gets constructed by WebLogic itself. All that you have to do is provide 3 or 4 pieces of information. This one, database name, port number, host, password. Once your test is good, move on to next. And this is where you target your data source. See, all this time we have been creating the data source on the admin server. We never really said where the data source is going to be available, and this is that time. So wherever you say, whichever JVM, it will bind to the local JNDI of that JVM. So you can pretty much target it to all the servers where your application is actually running, or you can target it to all the servers even if there is no application like admin. So there will be only a data source, but nobody is going to use it. So either way, so I'm targeting everything here just to show you some additional things. So usually you will target it to all the servers where you have the application deployed, because the application is going to use this data source. So target it to all the JVMs and finish it. That's it. The data source is ready. Now you can see the data source status by going in there. Data source. You can look at monitoring tab. You can look at, see this one, the statistics. On this server, data source is enabled, it's running. On MNG1, it's running. Even though we have targeted to all the servers, see this one, we have targeted MNG2, 3, 4 also. But the status is not shown here because those servers are not running at this point. Alright, you can test it here. Alright, it should be in running state. Then the configuration of the connection pool. So go into connection pool here. If you go into connection pool, a connection pool is basically a pool of connections, right? Now the capacity of that pool is defined by these 3 parameters. Initial capacity means initial number of connections. Max capacity, the maximum number of connections it can grow up to, and every time it wants to grow, this is the number of the increment that we are doing. Means first it will, when the server comes up, the data source will bind to the JNDI. A data source has a connection pool associated with it. That pool initially has one connection object. Once the one connection object is used, it will create one more, or this capacity increment number of connection objects, and it will go on creating like that till it reaches a max. In a normal production setup, for a better performance, you will keep both initial capacity, max capacity to same, which means all the required max number of connection objects get created during the startup itself, so that your server does not spend any time in creating the connections. That way your performance will be a little better, and the capacity increment in that case will be pretty much irrelevant, because you are not going to increment your connection pool size anytime. It's already reached the max. Alright, so that's a connection pool capacity. Now let's go on with some additional things. Now out of all these things that we have configured, there are certain things that may fail. That's when your job as a WebLogic administrator comes into picture. The one thing that could fail probably is the connection pool itself. It's full, or there are no working connection objects. In that case, the connection pool might say, I don't have a connection. So application looks up the JNDI, gets a data source. When the data source checks with the connection pool for an available connection object, the pool says no connections available. The reason could be anything. Maybe the backend database is not available, or all the connection objects are getting corrupted. For whatever reason, the pool says I don't have a connection. Now in that scenario, obviously the application fails to acquire a connection object. The data source simply says we don't have connection objects. Now the question is, who is going to handle such a failure? Is it the application, or is it WebLogic? Who is supposed to handle it? This is a question for you. I'm expecting an answer from you guys. So if there is no working connection object, where should that error be handled? Should it be handled in the application or should it be handled at WebLogic itself? Whose responsibility is it?
Hello.
Yeah.
Yes, sir. I think so. Like as like WebLogic administrator, we will be like responsible for that. We can reset the
No,
connection. The
no, 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 no. We're not talking about which person. We're talking about which product. Is it the application? Is it the WebLogic server? A
WebLogic
WebLogic
server.
server. That's right.
Yeah.
That's right. Because the server is expected to provide a connection. Now, if it fails to provide a connection, obviously it's his responsibility to fix it. Now, to fix such a problem, a WebLogic provides what is called the next level of data source, a multi-data source. Let's look at that one. So what we are looking at is any failure to provide a connection object. When a data source fails to return a connection object to the application, either this is one way where where the application is actually handling the error. Application is simply saying, okay, let's look up for another data source. But if the application says no, it's your responsibility, you provide the connection object, then we have another thing. Let's see this one. So what we have is application 1 was actually looking for data source 1. If data source 1 could not be found, the error it can be handled in the application itself. The application will go on and look for data source 2. Obviously, this is not an ideal coding method. We are expecting the WebLogic server to handle such a failure because it's the WebLogic server's responsibility to provide a working connection object. Application is expecting a working connection object. So for that one, what happens is instead of two independent data sources, WebLogic allows you to logically combine those two data sources, and you call it a multi-source or multi-data source, either way. Now, in the application, we are not referring to individual data sources anymore. Instead, we are referring to what is called the multi-source. So multi-source is also an object on the JNDI. So now you have three objects: data source 1, data source 2, multi-source, MS1, let's say. Application does not know anything about DS1, DS2. Application only knows about the group name or the multi-source name MS1. Now the lookup and the coding of the application happens in such a way: look up the JNDI for multi-source. Multi-source is internally a logical grouping of data sources. So when a request arrives at multi-source, obviously application is asking for a connection object. So here the multi-source will look up each of the internal data sources. Means it will go into each of the internal data sources. Let's say first DS1. Assume DS1 failed. Now the multi-source is not going to tell to the application there is no connection object. Instead, multi-source will go to DS2. It will check if DS2 has a working connection object. If DS2 can provide a working connection object, it will be given to the application. So here, each of the data sources, obviously as usual, has a connection pool working with it. But the only difference is the application does not know anything about individual data sources now. It only knows about a group name. The internal checking or internal redirection of the request to which data source it actually goes to will be handled by the multi-source. Once a connection object is available with the data source, a connection object information will be given to the application. So that way, a failure at data source level can be handled by using a multi-source. Now usually in a very regular environment, you have an Oracle rack on the backend. Data source 1 usually targets to the node 1 of rack. Data source 2 usually targets to the node 2 of your rack. So that way, so you have the same database on the backend, but two instances which are connected through two data sources. That's a common setup you will have. Now, this is a failover that we are looking at. Means data source 1 failed, the multi-source will take you to data source 2. So as long as data source 1 is available, data source 2 never receives a request. That's one thing that you must understand here. This is a tricky part here. So let's say I'm looking at a failover scenario. DS1 is available, DS2 is also available, both of them running, no issues. So when a request comes in, request 1 goes here, request 2 also goes here, request 3 goes here, 4 goes here, 5. So like that, all the requests will go to DS1 only, because DS2 was never being asked for a connection. DS2, the request will come to DS2 only when DS1 has failed, which means in a normal scenario you cannot distribute these requests between these two data sources. So if your multi-source is being used for a failover mechanism, unless DS1 fails, the request never received go to DS2, which means DS2 is pretty much lying idle. So you cannot load balance and failover at a time because of this problem. If you are doing a failover, all the requests are coming here. If you are doing a load balancing, let's look at the distribution of the requests. Request 1 is here, request 2 is here, the same way request 3 is here, request 4 is here. Now obviously when such a distribution occurs, we are not failing over from DS1 to DS2. Means at any point, let's say the multi-source has decided based on its load balancing algorithm that request 4 has to go to DS2, but DS2 has failed. Let's say DS2 has failed. If DS2 failed, obviously the request will be internally redirected again back to DS1. So even though we are using a load balancing algorithm, the internal failover will still take you to the other data source. Now the point being here is either you can use failover or you can use load balancing. Only one of these two at a time with a multi-source. If you are using a simple failover kind of thing, your requests, all of them will reach only the first data source. If this fails, then all the requests will go to DS2. It's never distributed like this. So a multi-source, when you are creating, you have to define whether you are going to use it for failover, in which case only one data source is going to take all the load, or you're going to use it for load balancing. In that case, the multi-source will distribute the load across these two data sources. But again, even in a load balancing algorithm, when the data source fails, all the requests will still fail over to DS1. So load balancing internally uses the failover again. So here in the failover list, what we are looking at simply an ordered list of data sources. DS1 will receive all the requests as long as it is available. DS2 and 3 will be idle. If DS1 fails, DS2 will receive all the requests, like that. So your multi-source is going to simply check through this ordered list. Whichever provides a connection first will get the connection, will give the connection object. Entire list is basically checked every time as long as it finds a connection and a data source with a working connection object. Now, as I said, load balancing. This is pretty much DS1 first request will be received. DS2 will receive requests only when the DS1 fails. So this is the important point we were talking about. A multi-source or a multi-data source can use a data source only from that what is it? Yeah, this is a regular thing. Yeah, this is not so important. It's pretty logical by now, I think. Basically, a multi-source can use a data source only from that JVM because you are combining them together, right? They should exist on the same JNDI. So data source 1 and data source 2 should exist on the same JNDI. Then only you can combine them together. And this is what we are interested. I was looking for actually. The load balancing versus failover. Look at the load balancing scenario. You have application 1 here. Request 1 will flow to DS1 through the multi-source, which is here. So here you have a multi-source with 4 data sources. Request 1 will flow to DS1, 2 will flow to DS2, 3 will flow to DS3, like that. Means the request is already load balanced at multi-source. In this case, MS1 was configured to balance the load. Whereas this one, failover, all the requests, request 1, 2, 3, 4, all of them will come to DS1 only. If DS1 fails, you will go to DS2 then. If DS2 fails, then the request will go to DS3. So there's a slight difference between load balancing and failover. And when we are creating a multi-source, you need to choose what algorithm or what are we going to use it for. Usually a multi-source is never really used for load balancing. It's always used for failover. That's actual scenario we have in real time. Apart from that, so obviously both load balancing and failover cannot be implemented at the same time. Only one needs to be selected during the creation of the multi-source. Now let's see the creation of the multi-source. You will get a better idea then. So here the same stuff here. Earlier we have created a data source. Now you can create a multi-data source. Now the third thing you are looking at, data source factories, is actually a deprecated feature. It's for backward compatibility. Earlier there used to be what are called data source factories. Those factories will provide the data source, which will actually let you connect to the connection, the database. Now they are not being used, but still you have it for backward compatibility. Now here we are looking at these two parts. Data source we have already created. You can create a multi-data source. Obviously for a multi-data source, you need multiple data sources. Already we have only one. So let's say we create another data source, DS2. DS2. Go by the same naming convention. Type of object, name of object. Oracle database again. Once you select the database, all the drivers automatically get loaded. So I'm going to select thin XA driver. What's XA driver? Anything that supports a two-phase commit protocol is a XA driver. So move on to next. Doing it a little quickly. Database name is encode IT here. Host name is the one that we are running. Port number 1521. Jdbc. Encode IT. Encode IT. Move on to next. So these details are already filled. The URL is automatically created. Test the configuration. It's good. Move on to next. Target it. So let's say I'm targeting everywhere. Finish it. So you have two data sources. Now let's combine these two things into your logical multi-source. So go to multi-source, multi-data source. Create a new one. Now give any name to your multi-source, MS1. Now this name is important. This will come to you from the developer. Type of object, Jdbc. Name of object, multi-source. Now here you're going to tell what type of algorithm it's going to use, whether it's for failover or for load balance. So normally let's say we use it most of the times for failover. So select failover, move on to next. Target it, because multi-source also should be available on the JNDI. So move on to next. Now this multi-source, obviously we are grouping together data sources. When you're grouping together, you can group together only similar items. So only XA drivers can be grouped together, or non-XA drivers can be grouped together. Let's say we want to type XA drivers, so it will list out all the XA drivers available on your system. So you got two XA drivers. You can select all the members you want. So let's say I'm selecting these two to be part of a multi-source. So once they are selected, finish it. That's it. You got a multi-source available on these targets. And this multi-source has two members, DS1 and DS2. Now once your application is deployed, it's the job of the application to look up JNDI and it should find a multi-source. So here servers, let's see if we can look up the JNDI tree. This is the JNDI tree. Jdbc, yeah, here we go. See, all this time I've been telling you about JNDI, right? So I'm showing you how a JNDI looks like. This is servers. Go to the servers. Any of the servers, pick up any of the servers where we have the JNDI. So let's say we pick up the admin server. So you have admin. Look at this one, view JNDI tree. Click on the view JNDI tree. It opens a new tab. This is your JNDI tree for admin server. It has a lot of objects. These are all objects bound to the JNDI. These are all management objects we are using for console access. Then there are JMS related objects. The one we are interested in is Jdbc. You see, there is a multi-source. There is a data source 2. There is a data source 1. And there are internal WebLogic related objects also bound to the JNDI. So this is all services offered by, the JNDI service offered by WebLogic. So we have bound our own objects to the JNDI. Application can look up this table, find the data source or multi-source, proceed with whatever it wants to do. Alright, any questions here? We're going to talk a little more about the Jdbc during performance tuning, because there are some areas of Jdbc that needs to be tuned for better performance. We're going to come back to this Jdbc and talk about it. But for now, you will be working most of the times with the data sources and multi-sources. Any questions? Any questions?
Hello?
Yes.
Yes, sir. So normally, what are the issues that we normally face with this Jdbc concept?
One is your connection pool size not sufficient, in which case you need to increase the connection pool size. Second thing, your database crashes. Our database does not allow the number of connections. You will have too many open files error. Now that could be another problem is too many processes problem. So those two things that needs to be set up, especially if the process problem, we have a setting in database to increase the number of processes. The DBA will do. The open files also, and as a setup, you are going to increase the hard limit and soft limit of the number of open files. That's another problem, commonly coming problem. Another thing, if your database is not stable, so basically if nodes of your rack are going down, then what usually happens is if the database is down, WebLogic already knows that it cannot provide a connection object, isn't it? Because the database is down. Now instead of providing a non-working connection object, WebLogic disables the port, or WebLogic disables your data source. So here, if you in a scenario where the database crashed, let's say database is not available, if you go into data sources, DS1, let's say DS1 is trying to connect to a database, but it's not available. In that case, if you go into monitoring tab, statistics, you're seeing enabled equal to true here, right? You will see false there, means it's not enabled anymore. You cannot hear me?
Yeah, I can hear you. Okay, Deepak.
Deepak can, okay. I think there is some glitch or something. Okay, so we are talking about the problem. So the scenario here is about the problem. The database crashed. The moment database crashed, obviously WebLogic knows that, okay, database crashed, so I can't provide a connection object to the application. In that case, instead of providing a non-working connection object to the application, WebLogic simply denies a connection to the application. WebLogic says no connection object at all. It basically disables your data source. So you will see this problem in real time. The problem would be all the data sources get disabled. The moment a database crashes, all the data sources here, they will be automatically disabled. Now the disabling thing, automatically they should get enabled once the database is up. Normally what happens is last I think couple of weeks before we had a network problem. Means there was a problem between the WebLogic boxes and the database rack boxes, two boxes. So WebLogic thought database crashed. So there are lots of errors in the logs that could not connect to the database. Network adapter error, that's what you will see usually, IO error. But actually that was a network problem. So it was pretty much automatically resolved in just a fraction of seconds. So during that time, by the time the WebLogic realized that the connection established, it already has disabled the data sources. Now after 10-15 seconds, the data again the connection was established. Now is WebLogic supposed to automatically re-enable them, or we have to manually do it? What should be done?
We have to manually do it, right?
Why is that? Isn't it good that WebLogic does it for us? Wouldn't it be good, or wouldn't it be a better approach?
But I think the request should be denied by that time, right?
The request would be denied by what?
By the time when it senses that database is crashed and the network is not available, the request should be denied, right?
Yeah,
So,
whatever has failed, but we are talking about enabling the data source so that an incoming request can be handled from that point onwards. It's like database crash. Let's say in a real scenario, database crashed. Our DBAs are very good, so they brought up the database back within 5 minutes. Now in these 5 minutes, WebLogic has disabled the data sources.
okay.
Now the database is up in 5 minutes. So is it us as a WebLogic admin, we have to manually enable DS1, or WebLogic can do it for us? What's a better approach?
I think so. In real time, we normally untarget and target it, right? So,
Target and targeting is okay. Let's say we are not talking about targets. The targets are still same. Ideally, WebLogic is supposed to re-enable them. That's in theory. Means WebLogic senses a database crash, disables it, so that application is waiting for the connection objects. Then database comes up, WebLogic is supposed to re-enable, but it does not happen in reality. In practice, we have to manually enable them. Now manually enabling can be done only through WLST. It cannot be done using console. Another way of doing enabling is to restart the servers. So you can start the JVMs to re-enable the data sources, or for manually enabling through command line, we can use a simple WLST script that does it for us. I think I have that script somewhere. During WLST we're going to talk about it. Cat cd scripts. No, we have a very simple WLST script. It basically connects to the database. Sorry, it connects to WebLogic. It enables it. I'll show you where it is. Anyway, I'll show you that one. So the point here is either you have to manually enable all the data sources in the event a database crash. Database crashes, your data sources get disabled. Then either you have to restart the JVMs that will enable the data sources, or you can simply execute a script, WLST script, to enable the data sources. That's a second type of problem you will have. Another type of problem would be database locks is something that you will come across. So when there are database locks, means basically your code is written in such a way the rows or the tables on the database, they get locked. In that case you will get a lot of errors and a lot of requests will time out, and WebLogic gets all the stuck threads. That's another common problem in this region. Apart from that, sometimes your SQL queries, if they are too long, especially if indexes are not created, they will time out. So that's another common problem you come across. These are common problems. Especially the data source enabling thing, disabling thing is a WebLogic related more of. The rest of them are either operate on OS related or application related. Depending on the error message, we basically proceed with the troubleshooting.
Okay. Thank you.
Alright, any other questions? Okay, if you don't have any questions, you can disconnect. I'll upload this video. I'll send you that link. We are done for today, and tomorrow we're going to talk about GMS. So that's really important. So, and make sure your practice is on track. So we're almost approaching probably another 10 sessions is what we have. Halfway we are through. Alright, if you don't have any questions, you can disconnect, guys. Thank you. Thanks very much.
Okay. Thank you.